Alrighty, welcome back to this 9th session here. I've been making the point that discount rates are important, and there is a tendency to shop for a discount rate over time historically. Remember earlier on I talked about how wasn't until the 50s until we started to get standardized rules about how to do benefit cost analysis, to really start the Green Book, how to standardize how we do this. Now, over the years, over the 50s and 60s and 70s, we have some issues, and there are several issues with regard to how we're going to deal with this stuff, and I'll try to get through some of them in the benefit cost case study discussions that are going to come up in the next session and a little bit into this session. I've already showed you that if you want to justify a project and relative to its costs, we remember what we have to remember. If the costs of something are expensive and lumpy and they're up front, there's relatively little of that that's being discounted back to the present. That value is relatively well known. We know what it takes to build a bridge or a road or a dam. We know the costs of how to do that. So we know those values, and we know the costs of maintenance over a time period. Now, the benefits, remember, the benefits can be a little bit tricky over a longer time period. And by choosing a lower discount rate, you can inflate the benefits. And I just got through arguing that we have an obligation to choose a reasonably low discount rate. So imagine what I'm trying to do is I'm trying to justify a flood control and a water supply and a recreational project that the Corps of Engineers might invest in, and at a 3% discount rate over a benefit stream, and by the way, this would have several different years on its benefit stream. If it's done properly, the Corps of Engineers is allowed to use a 100-year time horizon on water projects. Now, you figure out whether you think that is reasonable or not. But they also use a 100-year time horizon on benefits as well, which is just goofy as could be. But they often use, and we often allow there to be a 20, 25, or even a 30-year, just like your mortgage, a 30-year mortgage, 20, 25, or a 30-year time horizon. Well, now let's assume just in general that there's a 20, 30-year time horizon and a 3% discount rate. And at 3%, the project comes out looking like it's generating net benefits. But the more appropriate discount rate maybe should be a little bit higher. Maybe given the way society is, where the economy is, maybe given what government is trying to do relative to the pace of private investment, that a more appropriate discount rate would have been 5%. Well, how do we figure out what the appropriate discount rate might be at a given point in time? Are you going to leave it to me, or are you going to leave it to somebody else? Well, the way I deal with it is I do my calculations just like I did on the example previously. I give people answers at several different discount values so that they can see the sensitivity of the responses to several different discount values. But ultimately, for the federal government and or for policy decisions, we got to have an answer. Somebody's got to say, we need this done at a specific discount rate. Now, either the analyst does it and defends it and has the discount rate accepted, or the government says you will calculate these costs and these benefits over this time horizon using a discount rate that we determine. Now, this got so bad over the years in the 1980s or in the 1990s that state and federal governments actually just flat threw up their hands and said, you got to use a discount rate that we say. And it was almost an arbitrary rate. At one point, we had to do all of our analysis with a 7% discount rate, which was relatively high. But remember, in the 1980s, inflation was high and all kinds of things were different. The value of money and our preferences for investment were expressed differently than they are in the current environment and the current economy. So I saw discount rates that were mandated on medium-term projects back then that were as high as 9%. And these were by the government. And the reason was because different agencies were using their own discount rates. Well, OMB Circular A94 has been around for a long time. And what it is, it's just simply guidelines and discount rates for benefit cost analysis of federal programs. So I thought I'd open it up here. And I'm going to go out of here. I'll open it up. I think I've got a link to it right here. See if this opens up properly. Yep. And let's see if I can make this a little bit bigger. Basically, what it is that it is a memorandum to heads of executive departments and establishments, and what it is it provides guidelines. And I'm just going to look at the table of contents of this thing. But it talks about what benefit cost analysis is, and it expresses the general principles that the net present value must be related to tangible outcome measures. It also talks about what cost effectiveness analysis is, and I'm going to talk about that in a second. And it just identifies the elements of benefit cost analysis. It tells about how to do this, how to measure this, how to treat inflation, and that we have a preference for dealing with what are called real or inflation-adjusted numbers. And then it has a discussion on the discount rate policy and how that might apply to some federal projects and procurements. It talks about how do we treat uncertainty, things that I've been talking about here. So when you read this, you'll get a sense of how we might do this. One of the things under number 9, under the treatment of uncertainty, is sensitivity analysis. We may, in sensitivity analysis, make different assumptions about the future. Maybe in my analysis, I change my assumption about population growth or income growth, and I produce results that are different. Yes, okay, and then there's several things there that are important, and a lot of it. Now, I want you to go down, though, and what they do in Appendix C is they actually give us discount rates to use when we're doing, and they update these every year. So if I clicked on this now, I'm going to see what it says. It gives us a set of nominal, which are not inflation-adjusted discount rates, and it gives us a set of real interest rates, or the rate after accounting for inflation that we think is going to happen. So let's just go back up to the nominal interest rates. Remember when I said maybe a water project might apply a 3% discount rate? Well, on a 30-year project, which is what I have here, OMB is saying, we're thinking something closer to 5% ought to be the appropriate rate to apply to this kind of a project. So what they're doing is they're giving us an example of their evaluation of short-term uncertainty versus long-term uncertainty. Short-term, the interest rates are lower, 4.1%. Over the longer term, the interest rate is higher, 5%. So this is an example of how do we get the right kind of interest rate when we're doing, at least in this case, a federal project. Well, state and local governments oftentimes just simply default or defer to this in terms of generating their required discount rates. As a matter of fact, oftentimes now in projects, what they will write is that the project is to be evaluated, for example, assuming a 5% discount rate with sensitivity analysis bracketed around that discount rate. Let's say you go down to 4% up to 8%, just to show people what would be the difference in the benefits, the net benefits, and the ratios as the discount rate changes. And remember, the effect of the discount rate is much more powerful on the benefits side because those benefits trickle out over a long period of time versus the costs are known in the present because they're lumpy and they're up front. Okay, so the discount rate really affects the benefit calculations. Now, I want to flip this over, and something that also has happened over time. If you want to kill a project, you mandate an unreasonably high discount rate. Because what will that do? That will minimize the benefit, net present value of the benefit stream. And so you can see with regard to regulations, let's say we want to do something with cap and trade or carbon taxes or land use changes with regard to preserving soil. And we've calculated what we think are a reasonable array of benefits, and maybe there's pressure by agencies or organizations or private groups to apply a higher rate, to not use the social rate of preference, but to default more to a private rate of preference, that these benefits ought to be valued in the market and they shouldn't be considered so much social benefits as they should be considered private benefits. And so they'll try to push for a higher discount rate, an exemption from these kinds of restrictions, to try to lower the benefit stream. You see how this stuff can be manipulated. Well, as long as you can see how it can be manipulated, you can't be manipulated. And the goal here is for you to be a smart reader of this stuff, more so than a smart doer of this stuff. If you want to do this stuff, you got to take a whole nother class. But if you want to be able to evaluate this, you need to be able to ask important questions. Is the time horizon reasonable? Were the benefits determined using assumptions that I can literally swallow? Does it make sense? Does it seem appropriate to the situation and the condition? Is the benefited area in the population who I think it should be, or have they overdefined the territory? And is the discount rate reasonable? These are all things that you can do as an analyst and an evaluator to make sure that benefit cost is done appropriately in your presence. So that's why we go here. So make sure you read the Circular A95. It is, again, not that long, and it's I think, interesting reading. And again, it should validate a lot what we've been talking about. So let me get this back up, and we're gonna just do a very short piece here. We use this. I want to show something here. Now, this is from 2007, the same thing that I just got done showing you. And I want to show you that the rates are much higher. Here's the 30-year discount rate was not much higher, but 5.1%. But look at the near-term rates. They're almost a full, this is just 2 years ago. They were almost a full percentage higher than the rates that I just got done showing you. Now let's go down and look at the next year. Oh, more than a full percentage. I'm sorry. These are the new rates. Here, I'm going to go back up. These are the 2007 rates, and at year 3 it was 4.9 or almost 5%, and at year 30 it was 5.1%. In 2007, there wasn't a lot of difference between the short term and the long run in interest rates. It was a little bit goofy. Now let's go down here. And now this is the present. And in the present, we're sitting in January 2009, we're sitting on a recession. We have all kinds of uncertainty. We got bank failures up the wazoo. We've got all kinds of things going on. Look at the gap between the short-term interest rates or discount rate through 2.7% versus a 30-year discount rate, 4.5%. A huge gap in the certainty, a huge gap in the costs of borrowing, and a huge gap in assumptions about stress down the road and in the future. So the difference between short and long term is quite a bit here, quite a bit. And so these are the kinds of things that happen from year to year with regard to this discount rate. It is a highly fluid and variable thing. So we look at this. Now I want you to also look at something else. This is atypical. The 20-year rate in this estimate is higher than the 30-year rate. It says, and what they're basically saying is that in the next 20 years we have more uncertainty than we do in the next 30 years. Now, why is that? I want you to think about that for just a second. Why would it be that in the next 20 years the government is feeling more uncertainty than it would when it looks out onto a 30-year horizon? And of course, you know the answer is me. Baby boomers. The baby boomers are going to put an incredible load on government operations, government activities, require governments to borrow more money, therefore raising the true cost of borrowing for everybody over the next 20 years. Over the next 20 years, the baby boomers now are just hitting 65. That puts them into 85. That's the original baby boomers. I'm the peak of the baby boomers. I'll be 75 in 20 years. I'll still be alive and kicking, and you're going to still be paying for me. But in 30 years, the odds of me being alive are much lower, much, much lower. And we're getting now where we're losing our baby boomers are dying off, and our fiscal accounts in government are going to get back into normal again. So this is interesting how this is reflected on these rates. Okay, let's talk about some other issues. First thing I want to talk about. When we calculate benefits, we're not going to look at what's on the screen right now so much. When we calculate benefits, I've already told you this, what we try to accumulate for people is enhancements to their well-being by lowering their costs, increasing their incomes, or making it possible for them to accumulate more desired private goods or public goods than they would have otherwise. And so their benefits tend to be related to money in some way or another. Their costs of living go down, their ability to buy more things with the money they have goes up, and their overall material well-being goes up. And so that's how we measure that kind of thing. That's a traditional benefit cost analysis, and maybe we look at a situation, we're improving a highway, and we're figuring out the cost, the reduced cost to business because travel times go up. Remember, time is money. Travel times go down, cost of operation goes down, efficiency goes up, productivity increases, all benefits for business. Same thing happens to consumers. The cost of going to work go down, the cost of operating your vehicle goes down, your probability of having an accident or dying on the road goes down sharply. So you, on average, realize a whole lot of benefits. Now, we can do this very well on lots of things that we know a lot about. But then there are lots of areas where the benefit cost analysis are all over the place, and they've been done over a number of years using a number of assumptions and maybe looking at just one part or a part of something and not all of something. So what many people who have been doing benefit cost analysis have done over recent years is they've started to adopt something called a meta-analysis or a super-analysis. And what they do, they actually compile the results of many similar studies. And then they bring all of that information, they make it into the present, they make this information current information, and then they use current benefits calculations to determine benefits as well as costs. So they might have a period of studies about any number of things over the last 5 years, whether it's national park usage or library usage, or programs designed to drop or to eliminate dropouts in high schools, or programs designed to minimize teen pregnancies. So you might do this with just one or many different types of things. You might think of a very broad approach to dealing with people's needs. So I have an example, a case study, and we're going to look at that in the next lecture. We're going to talk about this a meta study that looks at trying to achieve a very wide array of goals, and they use a study of hundreds of different types of research to try to come up with an evaluation or an estimate of benefits as well as costs based on different kinds of strategies of public intervention designed to help youth. So that's a good set. So we're gonna take a look at that down the road, and a summary of some of these case studies, by the way, is in your reading. So you can read that summary to get a sense of what we're looking at, as well as the case studies. Now, the Department of Interior has done something like this as well. As a matter of fact, they've done it almost to a fault. In their case, remember the example I was trying to give you about how do we value our recreational opportunity? Well, the Department of Interior has done something like this where they've studied a bunch of studies of valuing recreational activities and opportunities all across the United States, and then they calculated using a meta-analysis sets of rates then should be applied for a particular class of opportunity. For example, if I have an opportunity to go and go visit a beach and go swimming, that has a value, and or bird watching or hiking or any of these kinds of things, and that I can aggregate these values. And not only could I aggregate these values, but I could also aggregate the characteristics of the people who attended or came to these kinds of things. Well, it's heavily weighted. Now here's why I don't like it. It's heavily weighted towards large national parks. Well, large national parks are things that people, families drive to from a long ways away in a full car of people, and then they tend to spend an extended amount of time interacting with that opportunity. And so you might use this for the Department of Interior, and it applies really well to Yosemite and Yellowstone and Glacier National Park and Zion and Arches and the Grand Canyon and any number of things that are just simply fantastic that people take advantage of. Well, would I use that same kind of super study of all of these activities to ascribe benefits to a man-made lake in southeastern or southwestern Iowa that's basically 1 mile by 1 mile in size? No, I wouldn't. The number of people that would come would be different. People's implicit valuation of that relative to the grandeur and the beauty and the opportunities of Glacier or Yellowstone or Yosemite versus a square mile worth of a lake in Iowa. Well, it's different. It's apples and oranges. And so sometimes it's not appropriate, and I take issue with it. Same thing. We have issues with trying to figure out whether something is environmentally beneficial, and we've got a range of conclusions, for example, about biofuels. It's a current controversy. And one of the ways that they said, we can't figure out who's right, so what we're going to do is average everybody's studies and say, well, from this point forward, we're just going to go with the average of everybody's studies. This group says they're low, this group says they're high. We're just going to average all their studies and move forward, and we're just not going to think about it anymore. Well, I would argue that that's also incorrect, that we have obligations as scientists to keep striving for certainty and to not punt on third down just because something's difficult. So we do meta-analysis to try to give us an idea of benefits or an idea of potential costs of different types of options, but sometimes it's not appropriate. However, sometimes it is, and maybe you have an array of dropout prevention programs that you're doing either benefit cost analysis or cost effectiveness analysis, and they're reasonably recent. They've been done in the last 10 years, and you could look at those studies and calculate either the mean or the median set of values and say, okay, am I kind of like the median in my experience if I'm in Sioux City, Iowa, or if I'm in Colorado Springs, Colorado? Am I kind of like the median? And if I am, do these seem reasonable to me? Does this give me a set of reasonable expectations? So sometimes we use this meta-analysis or this averaging of many studies to determine benefits when we're just not very good at determining the benefits ourselves given our situations. Another thing that we do in benefit cost analysis, but it's not benefit cost analysis, is called life cycle calculations. And basically, what life cycle calculations may involve, it's either determining the costs or some other important consequence from the beginning of a certain activity all the way to the end of an activity. For example, I might do life cycle analysis of what are the economic, land use, and environmental, many different categories of environmental consequences of taking conservation reserve land, which currently is not being used, it's idle land, and making it cropland for some reason, whether I want to produce biofuels or something else. What is the entire life cycle consequences? What have I done? What do I do in terms of of the region's economy over a period of time? What do I do in terms of land use in my area, both directly and indirectly? And then what do I do with regard to the environment? I have soil runoff, and that contributes to the hypoxia zone in the Gulf of Mexico. Or because I'm tilling the ground now, I have carbon now is being released into the atmosphere. And I have those consequences. So life cycle calculations are more towards calculating multivariate consequences of public and or private decisions, not just the very simple tangible benefits and tangible cost calculations that go into a benefit cost analysis. Life cycle analysis is something that we may do on the way to making one heck of a benefit cost determination. I'm going to show you one down the road here in the next lecture. But it's something that we do. Traditional benefit cost analysis tends to concentrate on bridges, roads, canals, locks and dams, those kinds of things. I want to give you I'm going to close out this lecture, and you all know exactly what I'm talking about. But this is one of the most interesting and least obtrusive benefits that we've seen in society in recent years, and it fits very well with the current environment of trying to maximize, minimize our fuel use and maximize our overall family life efficiencies. In the last decade, but especially in the last 5 years, if you live in any urban area, you have seen your traffic lights now controlled by sensing systems that actually evaluate the traffic coming down the road, whether it's going to turn left and whether it's going to turn right. And what it does is it manages the traffic flow by switching the traffic much more efficiently and effectively so that it improves the flow of traffic north, south, east, and west. And you see these everywhere. And what does that do? Well, it increases the traffic flow, meaning highways and intersections are managing more traffic per hour and per minute than they used to, meaning a complete transaction, making it through the intersection. The other thing that's going on is that business costs are going down, household costs of obtaining goods and services and going to work, and the fact that my time sitting at a red light is wasted time that does nothing but irritate me. Well, that's gone down. And you haven't even noticed it. Or if you have noticed it, you're maybe appreciative of it. As a matter of fact, we're probably now getting to the point where we criticize these things because they're not quick enough. Well, 10 years ago, you sat and waited at a light. Everybody sat and waited for a light. Or you sat and waited for a light of a short cycle, and it took 3 lights before you got traffic through a specific intersection. But now we have these smart things. Again, perfect benefit cost analysis. What were the costs of this installation and maintenance over some reasonable time horizon relative to the improvement in community well-being, improved traffic flow, decreased accidents? Because you have improved traffic flow, you have better vehicle efficiency, lower fuel consumption, better returns to households, better returns to businesses, and better returns to the environment. And all you thought it did was switch your lights on and off. Look forward to seeing the next lecture, and we'll be wrapping up this session and this class and that lecture plus a little bit of a piece on the last assignment. Look forward to seeing you then. Adios.